Assalamu alaikum everyone. I am Muhammad Asif. I am a PhD scholar from BZU, Pakistan. I am Today we are discussing about the simultaneous detection of Anaplasma marginale and Theileria annulata in blood samples of horse and donkeys that were collected from South Punjab. In introduction, we know that Pakistan is a agriculture country, and we have a lot of livestock animals. We have selected the equines. In equines, there are horse, donkey, and mules. They are used for daily income, transportation of the people, carriage of the goods, and agriculture purpose. There are many diseases in different types of livestock. We have selected only two, the anaplasmosis and theilerioanolysis. Both are tick-borne diseases. One of them is due to the gram-negative bacterium, and other is due to the protozoan parasite. This is the life cycle of anaplasma. Basically, it is a tick-borne disease. So, with the help of ticks, it can transmit from one organism, one host to the other host, and also that is the Theileria annulata. It is a protozoan, so it can change from one life stage to the other life stage, and from tick to the horses or the equines. The aim and objective was to detect the Anaplasma marginale and Theileria annulata in blood samples of the equines, also to report the potential risk factor associated with anaplasmosis and Theileria annulata, also to demonstrate the effect of these parasites on the hematological parameters of equines from the concerned district. DNA was extracted by inorganic method. We have collected about 195 animals that were quite healthy. PCR was done. The annealing temperature was 56, and we done about for 30 cycles. Also, in addition to PCR, we also done the CBC with the help of analyzer. The statistical analysis was done. We apply the t-test and feature exact test for the analysis of the data. This shows the gel picture. Some of the samples were co-infection, like this sample and this sample. Uh, this animal was co-infected by Anaplasma marginale and Theileria annulata. These tables show the prevalence of parasites in horse and donkeys. We also detect the correlation of the prevalence of the parasites with the sex and the age of the animals. This shows that more female were more prone to disease as compared to the male organisms. There was no correlation with the age, but with the sex, gender and the sex, the more females were more prone to disease as compared to the male organisms. This table also show the significant correlation with the gender. These tables show the effect of presence of the parasites on the different blood parameters of the organisms, and these parameters are highly significant. Due to the presence of the parasites, there is elevation and decrease of the these parameters in both the parasites. In case of Anaplasma marginale and in case of Theileria annulata, both the horse and donkeys were affected. This is the phylogenetic tree of the partial gene sequences. In sequencing, we have done with 3 strains for Anaplasma marginale. They were identical to the Israel and Iraq samples. In case of Theileria annulata, we reported the 2 strains that were identical to the Indian and the Pakistani strains. Conclusions: we have used the multiplex PCR for the simultaneous detection of Anaplasma marginale and Theileria annulata in equine samples for first time in Pakistan. The female horse and donkeys were found more susceptible to both the parasites and the other infected animals had severely disturbed blood count. We recommend this technique to the livestock owner for the prophylactic detection of Anaplasma marginale and Theileria annulata in different animals, not only in equines but also we can put them into the cattle and the other herds. Thank you so much.